Hey everybody, this video is on exponential decay functions, which bear great similarity to exponential growth functions, with one significant difference, which is that these functions have quantities which are decreasing over time. Like the exponential growth functions, they do not have a constant slope. The slope is negative as you move left to right because their value is decreasing over time. But the amount it decreases is less and less and less each time, even though the percent change is constant. If it were a thing where you're losing, if it was negative 5% change or negative 5% growth, 95% of the quantity would remain after each time period. So the number that you're multiplying by, d, is always going to be between 0 and 1. Obviously, you multiply by 0, you get nothing. These functions will never get to nothing. Even if you lost 99% of something every single time, there'd still be 1% left. And then that 1%, you'd lose 99% of that, and you'd still have something. You'd be approaching 0, you would never get to 0. Your slope would approach 0, it would never get to 0. It would still be just slightly negative. It's important to note that in some of these equations, you may get an answer that's larger than what you started with, but that will only be in the case of if you are going back in time. Using our example of losing 5%, you're going to be multiplying by 0.95 because after you lose 5%, 100% minus 5%, what's left? 95%, it's what's left. So every single time you multiply by 0.95, you get 5% less than what you started with. Now, if that were a positive number, and you start with 100, say it was 0.95 to the fifth, we would expect, if you started at 100, we would expect that in 5 time periods that you would have less. But in this equation, even though it's decay, if you had to the negative fifth, that would essentially be asking, what was it worth back here in time? So while it is called exponential decay, it's possible that your answer is a larger number because it's possible they'll be asked you, the question might ask you, if it's 100 right now, what was it before? And that should make sense that your answer is actually larger. To get there, you could divide by 0.95 5 times, divide by 0.95, divide by 0.95, divide by 0.95, or simply multiply by 0.95 to the negative 5, which is the reciprocal of those 5 divisions. Okay, so going into a little bit more detail on these equations, the number d is going to be the percent that's remaining after each period of time. After each period of time, it's the percent that's remaining. So it's important to know that when you have this equation, this is not going to be the percent change, okay, or the percent of decrease. You're going to take 100% and take away the percent that it's decreasing. That's what you get. So if you had a 1% change drop, it'd be 1.0 minus 0.01, and 99% remains. If you lose 10%, 1 minus 0.1, if you lose 10%, 90% remains. If you lose 90%, you'll be multiplying by 0.1. Why? Because you've lost 90% and you want to find out how much remains, which is 10%. So this would be extremely rapid drop. You'd lose 90% each time period, but again, you would be approaching 0, but you would always have a slight amount that's greater than 0. Okay, so here are 2 practice problems for you. You need to write these out. Please write the equation that describes, in terms of y, the population in Rhode Island in 2 different situations. The first one is if Rhode Island's population, which we're going to say is starting at 1 million today, if it shrinks 5% for 10 years in a row. So y is going to equal what number times what base to what power. Similarly, if Rhode Island's population grows 5% for 10 years, the population of Rhode Island, y, is going to equal what number times what factor to what power. Okay, for your second piece of homework, you have the situation where you've decided that gambling is a good idea and you've inherited or somehow gathered up a good bit of money, and you decide, well, you're going to consistently gamble over time. And it turns out that you lose, but as far as gambling standards go, you don't lose too badly. But every year you lose 10%. Every single year you lose 10% of the remaining money. Currently, you have $10,000 left. This has been going on for 10 years. Question number 1, what did you have 10 years ago? So this is in the past. Think about what that means. What will you have in 10 years? That's in the future. Remember, this is a decay situation, so remember what kind of number you must be multiplying by. Please write out the entire calculation as well as the solution. Okay, the last concept for tonight's homework is about the rule of 72, and in particular about the idea of half-life. Half-life is a way of simplifying how quickly something is decaying, how quickly something is decreasing. And the rule of 72 is not an exact rule, it's an approximation rule. It basically says that if you want to know how long it's going to take something to double or be cut in half with a given compounding rate, you could take 72 and divide it by the percent of change. Now these are going to be approximate values. Okay, so if you have something that's decreasing or growing by 2%, 72 divided by 2 equals 36 time periods. So if you have something decaying 2% per year, then it's going to be approximately 36 years before it's cut in half. Same thing approximately for growing. Not exactly the same, but close. If it's 10% decay, 72 divided by 10, it's going to be about 7.2 time periods for it to double or to be cut in half. Doubling if it's multiplied by 1.1, cut in half if you're multiplying by 0.90. Last one, 72 divided by 18, 4 time periods. So approximately, if you're multiplying by 0.82, 100 minus 18, and you multiply by 0.82, by 0.82, by 0.82, by 0.82, the starting amount should be cut in half in about 4 time periods. If you were going to double it, it would be times 1.18, times 1.18, times 1.18, times 1.18, and it should double in about 4 time periods. So for this last problem, I want you to test out the rule of 72 and see how accurate it is if you started with a starting quantity of 100. And on the first one, you'll check 100 times 0.98 to the 36. See what number you get. Does it get cut in half? Then do 100 times 1.02. And do that to the 36. Does it double? Is it close? So needless to say, you're going to do that for this one, and this one. Okay, please show all your work, and we'll go over your results when we're in class. Thank you.